To obtain a certification as a computer technician, proficiency in both hardware and software is required. In the first series, we are focused on hardware, followed by the second series, which covers software.
Our ultimate goal is to provide a highly valuable and accessible resource at absolutely no cost, aiming to empower all aspiring professionals to successfully achieve their career goals and unlock their full potential for growth and success. We are providing you with enough information to help you decide if becoming a computer technician is the right choice for you.
Hello. If you're interested in the computer field, let's dive into the basics of computer safety and professionalism, an essential skill in today's digital world. Let's start by understanding why this skill is essential for everyone.
In the context of computer safety and professionalism, the statements provided refer to guidelines and best practices that IT professionals should follow to ensure they present themselves and conduct their work effectively and safely. Here is an explanation of each point.
First, consider how computers enhance productivity. Whether it's for work, managing personal finances, or connecting with others, knowing how to use a computer efficiently is key.
Present yourself with a proper appearance and in a professional manner. Professional attire. Dress appropriately for the workplace, which may include wearing business casual or formal attire, depending on the organization's dress code. Grooming. Maintain personal hygiene and grooming standards to present a clean and professional image. Behavior. Exhibit courteous and respectful behavior towards colleagues, clients, and customers. This includes being punctual, polite, and demonstrating a positive attitude.
Now, let's talk about the tools you'll need to begin. A working computer and access to the internet are essential. This setup is your gateway to endless learning possibilities.
Discuss the tools of the trade and preparations necessary to deal with problems proactively. Technical tools. Familiarize yourself with and use the appropriate tools and software for diagnosing and fixing computer issues. This may include hardware diagnostic tools, software utilities, and troubleshooting guides. Preparation. Stay up to date with the latest industry developments, technologies, and best practices. Engage in continuous learning through training and certification programs. Documentation. Maintain accurate documentation of common issues, solutions, and customer interactions to streamline future troubleshooting efforts and improve service quality.
It's important to approach learning with the right mindset. Think of your computer as a tool to open new doors. Being proactive in learning its functions will make the process smoother. Talk to customers in a professional, productive manner. Communication skills. Use clear, concise, and professional language when interacting with customers. Avoid technical jargon unless it is appropriate for the audience. Listening skills. Listen actively to customers' concerns and questions and show empathy and understanding. Problem-solving approach. Approach customer issues with a focus on finding solutions. Provide accurate information and set realistic expectations regarding the resolution of their problem.
Use common safety procedures. Electrostatic discharge, ESD, and electromagnetic interference, EMI. Precautions. Use anti-static wrist straps, mats, and other ESD safe equipment to prevent damage to sensitive electronic components. Proper handling. Handle hardware components and tools with care to avoid physical damage and personal injury. Follow manufacturer guidelines for installation and maintenance. Work environment. Ensure the work area is clean, organized, and free of hazards. Secure cables and equipment to prevent tripping and other accidents. Apply the best practice methodology to resolve problems. Structured approach. Follow a systematic approach to troubleshooting, such as identifying the problem, gathering information, analyzing the issue, developing and implementing a solution, and verifying the fix. Root cause analysis. Determine the underlying cause of the problem to prevent recurrence. This may involve examining system logs, error messages, and hardware diagnostics. Documentation and review. Document the steps taken to resolve the issue and review the process to identify areas for improvement. Share findings with the team to enhance collective knowledge and efficiency.
Safety first. Always ensure your computer is equipped with the latest security software. This protects your personal information and enhances your learning experience without interruptions. What about solving problems? Don't worry. Start with basic troubleshooting steps like restarting your computer or checking internet connections. These simple actions fix most issues. Adopting best practices can significantly improve your learning curve. Regular updates, organizing files, and understanding basic software are practices that boost your confidence and efficiency. Stay tuned. There's lots more to come. Remember, the journey of mastering computer skills begins with these first steps. Embrace the learning process, and you'll find it both rewarding and beneficial. By adhering to these principles, IT professionals can ensure they maintain a high standard of safety, professionalism, and effectiveness in their work. This not only helps in resolving technical issues efficiently, but also enhances customer satisfaction and trust in the services provided. Next, let's move on to understanding the visible parts of a computer.
Computing devices such as personal computers, laptops, smartphones, and tablets function through a combination of hardware and software. The hardware includes physical components like the processor, memory, and storage. The software consists of programs and operating systems that instruct the hardware on what tasks to perform. Together, they enable the computer to execute various functions.
Here is a list of some of the common connectors on typical computer systems. The USB ports, Type A, Type B, Type C, that's used for connecting peripheral devices like keyboards, mice, printers, external storage, and smartphones. The DisplayPort. It connects to monitors for video output. The VGA port. It is an older, analog video connector, used for older monitors. The DVI port. It is used for digital video interface. The Thunderbolt port. It is a high-speed data, video, and power connector. Some of your older ports, like your SD card and optical drive, that's used for reading and writing CDs, DVDs, and Blu-ray discs. These ports are less common in modern systems.
There are other ports, like the HDMI ports. These ports are used for video and audio output to monitors and TVs. Then you have the Ethernet ports, RJ45. This port enables wired internet connections, ensuring stable and fast data transfer.
A typical computer systems also feature device components like hard drives, motherboards, and graphics cards. Graphical User Interface, GUI, allows users to interact with the computer using graphical icons and visual indicators. Command Line Interface, CLI, enables text-based interaction through commands. These components work together to ensure optimal performance.
Operating system software acts as an intermediary between hardware and user applications. It manages resources and provides a user interface for easier interaction.
Common features of operating systems include file management, task scheduling, and memory management. These features ensure efficient and organized operation of the computer.
File management. File system organizes and manages files on storage devices, providing directories and file hierarchies. File permissions controls access to files and directories, ensuring security. Memory management. Virtual memory extends physical memory using disk storage to provide more memory than is physically available. Memory allocation manages memory allocation and deallocation for applications. Device management. Drivers, software that communicates with hardware devices, enabling the OS to use them. Plug and play automatically detects and configures new hardware. Security. User authentication verifies user identities to control access. Permissions and access control manages user permissions to access resources. Encryption protects data by encoding it. Firewall monitors and controls incoming and outgoing network traffic based on security rules. Backup and restore, tools for data backup and recovery.
The synergy between hardware, software, and operating system like Windows, Mac OS, Linux, and Android incorporate these features ensures computing devices run efficient, secure, and smoothly. This combination is essential for modern computing needs. Okay, let's move on to CPUs.
The core components of a CPU include the Arithmetic Logic Unit, ALU, performs arithmetic and logical operations. Control Unit directs the operation of the processor. It tells the computer's memory, Arithmetic Logic Unit, and input and output devices how to respond to the instructions that have been sent to the processor. Registers, small, fast storage locations within the CPU that hold data temporarily. Cache, a smaller, faster type of volatile memory that provides high-speed data access to the processor and improves processing speed. The clock synchronizes the operations of the CPU with other components of the system. And the bus interface facilitates communication between the CPU and other components of the computer. These elements work together to process instructions and perform calculations.
The CPU interacts closely with the computer's memory. Main memory, RAM. The CPU retrieves instructions and data from the RAM, performs computations, and writes back results. RAM is volatile, meaning it loses its contents when power is off. Cache memory. This is a smaller, faster type of memory, located inside or very close to the CPU. It temporarily holds frequently accessed data and instructions to speed up processes. Virtual memory. This extends RAM onto the hard disk or SSD, allowing for more efficient handling of large tasks by providing the CPU with a larger address space.
Modern CPUs come in various types, including single-core, dual-core, quad-core, and even octa-core models. The choice depends on the performance, needs, and application requirements. Desktop CPUs, used in personal computers, designed for a balance of performance and power consumption. Mobile CPUs found in laptops designed to be energy efficient and generate less heat. Server CPUs used in servers and data centers, optimized for handling large workloads and multiple simultaneous requests. Embedded CPUs, built into embedded CPUs so they're devices like appliances, vehicles, and industrial machines tailored for specific control tasks. High-performance CPUs, for gaming, scientific computations, and high-end workstations, these CPUs prioritize performance with higher clock speeds and more cores.
Selecting a CPU involves considering factors like clock speed, core count, and thermal design power. Compatibility. Ensure the CPU is compatible with the motherboard socket type and chipset. Performance needs. Choose based on the intended use, for example gaming, video editing, general use. Budget. Balance performance and cost within your budget. Brand. Decide between AMD and Intel, considering performance benchmarks and personal preference. It's crucial to match the CPU to the motherboard socket type for compatibility.
To install a CPU, begin by aligning it with the socket on the motherboard. Once properly aligned, gently place it into the socket and secure it with the locking mechanism. Installation steps. Power down and open case. Turn off the computer and open the case. Remove old CPU. If replacing, carefully remove the existing CPU and clean off old thermal paste from the heatsink. Place new CPU. Align the CPU with the socket and gently place it in. Close the retention mechanism. Apply thermal paste. Apply a small amount of thermal paste on the CPU. Install cooler. Secure the cooler on top of the CPU. Close case and power up. Reassemble the case and power on the system to check if it is functioning correctly.
If the CPU fails to function correctly, several troubleshooting steps can be taken. Check for proper installation, ensure the cooling system is working, and verify compatibility with other components. BIOS/UEFI settings. Reset to default settings or update the BIOS/UEFI. Check for damage. Inspect the CPU and motherboard socket for bent pins or physical damage. Overheating. Check cooling system. Ensure the cooler is properly installed and functioning. Thermal paste. Reapply thermal paste if necessary. Case ventilation. Ensure good airflow within the case. System instability or crashes. Check RAM. Faulty or improperly seated RAM can cause instability. Update drivers. Ensure all system drivers, especially chipset and CPU drivers, are up to date. Scan for malware. Malware can cause performance issues and instability. Performance issues. Background processes. Close unnecessary background processes. Cooling. Ensure the CPU is not throttling due to heat. Software optimization. Optimize software settings for better performance.
Understanding the core components, memory interactions, and varieties of modern CPUs can greatly aid in selecting, installing, and troubleshooting CPUs effectively. This knowledge is essential for maintaining a reliable computer system. Let's move on to RAM.
Let's explore the essentials of DRAM packaging and the varieties of RAM available. Understanding these can greatly improve your system's performance.
First, let's identify the different types of DRAM packaging. Common types include DIMM, SODIMM, and RIMM, each serving specific device needs. DIMM, or Dual Inline Memory Module, is typically used in desktops, has a 64-bit data path. Comes in various forms including DDR, double data rate, DDR2, DDR3, DDR4, and DDR5. SODIMM, or Small Outline DIMM, is designed for laptops and compact devices. Similar variants as DIMM, DDR, DDR2, DDR3, DDR4, DDR5.
RIMM, on the other hand, is less common today but was used for high-speed applications. Knowing these types is crucial for compatibility.
Next, let's explore the varieties of RAM. The most common types are SDRAM, DDR, DDR2, DDR3, and DDR4, each offering different speeds and efficiencies. SDRAM, or synchronous DRAM, was widely used in the past. DDR, or double data rate, improves performance by transferring data twice per cycle.
Subsequent versions like DDR2, DDR3, and DDR4 offer even higher speeds and lower power consumption. Choosing the right type depends on your system's requirements.
Now, let's look at how to select and install RAM. First, confirm your motherboard's compatibility with the RAM type and capacity you plan to install. Check for the supported RAM type, DDR3, DDR4, etc., speed and capacity limits.
Next, power off your system and open the case. Locate the RAM slots on your motherboard. Align the RAM module notch with the slot, and gently insert the RAM modules. Press down firmly until it clicks into place, ensuring they're securely in place. Then close the computer case.
After installation, power on the system, and check if the RAM is recognized in the BIOS. This ensures the RAM is correctly installed and functioning.
Finally, let's discuss basic RAM troubleshooting. If your system isn't recognizing the RAM, recheck the seating of the modules and ensure the slots are clean. BIOS UEFI check. Ensure the BIOS UEFI is recognizing the installed RAM. Memory test. Run a memory diagnostic tool, for example, Windows Memory Diagnostic, MemTest 86. Swap modules. Test each RAM module individually to identify faulty modules. Check compatibility. Verify that the installed RAM is compatible with the motherboard. These points cover a comprehensive overview of the different types of DRAM packaging, varieties of RAM, how to select and install RAM, and basic troubleshooting steps for RAM-related issues. If issues persist, test the RAM in different slots or try different modules. Proper troubleshooting can often resolve common RAM issues efficiently. Okay, next, let's move on to motherboards.
Motherboards serve as the backbone of a computer, connecting all the essential components. They manage communication between the CPU, RAM, and other peripherals. Motherboard key components. CPU socket, the slot where the processor, CPU, is installed. RAM slots, slots for memory modules, RAM. Chipset, manages data flow between the processor, memory, and peripherals. BIOS/UEFI, firmware interface between the computer's hardware and its operating system. Power connectors, Provide power to the motherboard and its components. Expansion slots. Slots like PCIe for adding additional cards such as graphics, sound, and network cards. Storage connectors. Connectors for storage devices like SSDs, M.2, and HDDs. Modern motherboards come with various expansion buses like PCIe and USB, allowing for enhanced functionality. These buses facilitate faster data transfer and improved performance.
Upgrading a motherboard requires careful planning. Ensure compatibility with your CPU, RAM, and other components to avoid any potential issues.
When installing a new motherboard, align it with the case standoffs. Secure it using screws. And connect the power supply and peripheral cables.
Let's go through the installation steps. Power off and unplug the computer. Remove the old motherboard if upgrading. Install the CPU cooler and RAM on the new motherboard. Place the new motherboard into the case and secure it with screws. Connect power cables, data cables, and front panel connectors. Install any expansion cards. Power on the computer and enter BIOS UEFI to configure settings.
Post-installation, verify that all connections are secure. Power on the system and access the BIOS to set up initial configurations.
Troubleshooting motherboard problems involves checking for loose connections and ensuring all components are seated correctly. Listen for beep codes that indicate specific hardware issues. Check power supply. Ensure the power supply is working and properly connected. BIOS UEFI reset. Reset BIOS UEFI settings to default. BIOS UEFI update. Update to the latest firmware version. Error codes. Refer to motherboard manual for post-beep codes or onboard diagnostic LEDs. If the system still fails to boot, reset the BIOS by removing the CMOS battery for a few minutes. This can resolve many common issues. Regular maintenance and updates to the motherboard's firmware can prevent future problems. Keep your system running smoothly with periodic checks and updates. These points cover a comprehensive overview of how motherboards work, recognizing modern expansion buses, upgrading and installing motherboards, and basic troubleshooting steps for motherboard-related issues. Okay, let's keep moving. Next, power supplies.
Electricity is fundamental to computer operation. It powers every component, enabling them to function seamlessly. Understanding electricity basics helps in managing and troubleshooting electrical issues effectively. Let's break down the basics of electricity and its role in power supplies. Powering a PC involves converting AC from your wall outlet to DC, which the computer can use. This is primarily done by the power supply unit, PSU, a crucial component of any system. The 24-pin ATX connector supplies power to the motherboard. This is the primary power connector for modern motherboards. AC is a type of current where the flow of electric charge periodically reverses direction, while DC is a type of current where the flow of electric charge is in one direction. You have the SATA power connectors that supplies power to storage devices like SSDs and HDDs. These connectors are flat and thin. The Molex connectors are legacy connectors used for older devices such as some types of fans, older HDDs, and optical drives.
When installing a power supply, you must ensure that it has the right wattage for all your components. This is crucial for the efficient functioning of your system. Connect it securely to the motherboard, CPU, GPU, and storage devices to distribute power efficiently and prevent any potential issues.
Maintaining power supplies involves regular checks for dust, ensuring connections are tight, and verifying that the PSU fan is operational. Proper maintenance extends the lifespan of your power supply unit. This process may also include inspecting for any signs of wear and tear, checking the voltage output to ensure it is within the proper range, and replacing any faulty components. Keeping the environment around the power supply clean and free from obstructions can also help in maintaining its efficiency. Regular updates and firmware checks can further ensure that the power supply unit is functioning optimally.
Power supply troubleshooting starts with checking cables and connections. Ensure every cable is securely plugged in and in good condition. If the computer doesn't power on, the PSU might be faulty, and further inspection is needed. Use a multimeter to test voltage outputs for irregularities, ensuring all readings match the expected values.
If your PC shuts down unexpectedly, it could be due to the power supply overheating. Make sure you have proper ventilation for your system, and consider upgrading your power supply unit if your current one isn't able to handle the load of all your components efficiently.
Fire safety is critical when dealing with power supplies. It is essential to understand the risks associated with improper handling and storage. Keep flammable materials away from your PC, such as papers, fabrics, and other combustibles. Additionally, use surge protectors and regularly inspect power cords for wear and tear to prevent electrical fires. Make it a habit to check the condition of all electrical components to ensure they are functioning properly and safely. In conclusion, understanding electricity and power supplies is essential for any computer user. It's important to know how to properly install and maintain your power supplies, as well as to follow all necessary safety practices. This ensures that your system runs smoothly and safely, preventing potential issues or hazards that could arise from improper handling. Next, let's move on to mass storage. Hard drives are essential for storing data on computers. They use spinning disks called platters to read and write information using a read-write head. The read-write head moves across the platters to access data. This mechanical motion can impact speed and reliability over time.
There are various mass storage interface connections available, such as SATA, IDE, and SCSI. These connections link the hard drive to the computer's motherboard.
SATA is the most common interface in modern computers, offering better speed and flexibility. IDE and SCSI are older technologies but still in use for specific applications. To protect data, RAID, redundant array of independent disks, can be used. RAID combines multiple hard drives into a single unit to provide redundancy and improve performance.
Common RAID levels include RAID 0, RAID 1, and RAID 5. Each level offers different balances of performance, storage capacity, and data protection.
Installing a hard drive involves connecting it to the motherboard using the appropriate interface and securing it within the computer case. Proper installation ensures reliable operation and long-term data integrity.
After installation, the hard drive must be initialized and formatted for use. This process prepares the drive to store files and ensures it is recognized by the operating system. Okay, we've talked about how the hard drive works. Now, let's talk about partitioning, formatting, and troubleshooting hard drives.
Welcome to our guide on managing hard drives in Windows. Today, we'll explore partitions, formatting options, and how to maintain and troubleshoot your hard drives. Let's begin by delving into the various types of partitions that Windows offers for managing your storage space effectively. In the Windows operating system, you have the flexibility to create different types of partitions, including primary, extended, and logical partitions, each serving a specific purpose in organizing and storing your data. Primary partitions are essential for installing an operating system and are limited to 4 per disk. Extended partitions, on the other hand, are used to create additional logical drives within a single primary partition. Logical partitions reside within extended partitions and provide a way to further subdivide your storage space for better data organization. By understanding the distinctions between these partition types and their functionalities, you can make informed decisions when setting up your storage configuration to meet your specific needs and optimize data management on your Windows system. Primary partitions are bootable and can host an operating system. Extended partitions, on the other hand, can contain multiple logical partitions. Next, we'll look at hard drive formatting options. Windows supports several file systems, including NTFS, FAT32, and exFAT, each with its own advantages. NTFS is the most commonly used file system for Windows, offering robust security features. FAT32 is compatible with older systems, while exFAT is ideal for large files. When you need to partition and format a hard drive on your Windows system, you can take advantage of the Disk Management tool. This valuable utility built into the Windows operating system provides you with a user-friendly interface to efficiently manage your storage devices. Within the Disk Management tool, you have the capability to not only create, delete, and format partitions, but also adjust partition sizes, assign drive letters, and set partition types as needed. By using this tool, you can effectively organize and optimize your storage space to suit your specific requirements. Maintaining your hard drive involves regular defragmentation and error checking. These tasks help ensure optimal performance and longevity of your storage device.
If you encounter issues, troubleshooting steps include checking for driver updates and running diagnostic tools. Proper maintenance, including regular software updates and hardware checks, can prevent data loss and hardware failure. It is highly advisable to make a habit of regularly backing up your critical data as a proactive measure to mitigate any potential issues that may arise. By establishing a consistent backup routine, you can safeguard your important files, documents, and information against unforeseen events such as hardware failures, system crashes, malware attacks, or accidental deletion. Backing up your data not only provides you with peace of mind, but also ensures that you have a secure copy of your valuable information that can be easily restored in the event of data loss. Utilizing various backup methods such as external hard drives, cloud storage services, or dedicated backup software can offer you redundancy and protection for your data, helping you recover swiftly and resume normal operations without significant disruption. By prioritizing regular data backups as part of your overall data management strategy, you can fortify your data resilience and minimize the risks associated with data loss, enabling you to maintain productivity and continuity in your personal or professional endeavors. Moving on.
Welcome to our professional guide on wireless networking. In this video, we will cover essential components, standards, installation, configuration, and troubleshooting of wireless networks.
First, let's discuss the key components of a wireless network. Within this interconnected realm of digital communication, key components such as wireless routers, access points, network adapters, and antennas stand as the cornerstone elements that orchestrate seamless connectivity and data transmission. Wireless routers serve as the architectural foundation, acting as the central hub that facilitates the distribution of data packets across the network, enabling devices to communicate and exchange information effortlessly. Complementing the routers are access points, which extend the network's coverage area and provide additional entry points for devices to connect and access resources within the network. Network adapters, on the other hand, play a crucial role in establishing the vital link between devices and the wireless network, enabling seamless communication and data exchange. These adapters act as the bridge that seamlessly integrates devices into the network infrastructure, ensuring a cohesive and efficient flow of information. Furthermore, antennas serve as the unsung heroes of the wireless network, working tirelessly to transmit and receive signals across various distances and terrains. By harnessing the power of electromagnetic waves, antennas play a pivotal role in ensuring reliable connectivity and optimal network performance, enhancing the overall efficiency and effectiveness of the wireless network ecosystem.
As we navigate the ever-evolving landscape of wireless networking technology, it becomes imperative to delve into the realm of wireless networking standards that underpin the seamless operation and interoperability of modern networks. These standards serve as the guiding principles that dictate the protocols and specifications governing wireless communication, ensuring compatibility and performance across a myriad of devices and environments. Among the plethora of wireless networking standards that have shaped the digital connectivity paradigm, prominent names such as IEEE 802.11a, 802.11b, 802.11g, 802.11n, and 802.11ac have emerged as beacons of innovation and progress in the field. Each standard embodies a unique set of characteristics and capabilities that cater to specific requirements and advancements in wireless technology, paving the way for enhanced speed, coverage, and reliability in network communication. IEEE 802.11a, known for its operation in the 5 GHz frequency band, offers high data rates and improved performance in congested wireless environments, making it ideal for applications that demand robust and reliable connectivity. In contrast, 802.11b introduced the 2.4 GHz frequency band, delivering widespread compatibility and ease of deployment for a diverse range of devices. Building upon its predecessors, 802.11g combined the best of both worlds by offering higher data rates and backward compatibility with existing standards, fostering a seamless transition to faster and more efficient wireless networks. The evolution continued with 802.11n, introducing multiple input, multiple output MIMO technology to enhance throughput and range, revolutionizing the way data is transmitted and received across networks. The latest standard, 802.11ac, represents the pinnacle of wireless networking innovation, boasting unprecedented speeds, expanded coverage, and enhanced reliability through advanced features such as beamforming and wider channel bandwidths. By embracing these cutting-edge standards, individuals can unlock a realm of possibilities in wireless networking, empowering them to harness the full potential of modern technology and connectivity.
Understanding the unique specifications for speed, frequency, and range that come with each standard is essential when choosing the correct equipment.
Transitioning now to the practical realm of installing and configuring a wireless network, let us embark on a journey towards setting up a robust and efficient network infrastructure. The initial step in this process involves strategically placing your wireless router in a central location within your premises to ensure optimal coverage and seamless connectivity throughout your living or working space. By strategically positioning the wireless router in a central location, you can maximize the signal strength and coverage area, minimizing potential dead zones or areas with poor connectivity. This strategic placement facilitates uniform distribution of the wireless signal, enabling devices in all corners of your environment to access the network without encountering signal degradation or interference. Furthermore, selecting an unobstructed location for your router, away from interference sources such as walls, metal objects, or electronic appliances, can significantly enhance signal quality and network performance. By ensuring a clear line of sight between the router and connected devices, you can mitigate signal attenuation and optimize data transmission rates, fostering a seamless and uninterrupted user experience. Once the router is strategically positioned, the next step involves configuring the network settings to tailor the wireless network to your specific requirements and preferences. This includes setting up a unique network name, SSID, implementing robust security protocols such as WPA2 encryption, and creating strong and secure passwords to safeguard your network against unauthorized access. By meticulously following these installation and configuration guidelines, you can establish a resilient and efficient wireless network that not only meets your connectivity needs, but also ensures a seamless and reliable digital experience for all users within your network environment.
Configure the router settings through its web interface. Set up a secure SSID and password to protect your network from unauthorized access.
Identifying and resolving common issues such as interference, outdated firmware, and incorrect configurations are key aspects of troubleshooting wireless networks.
In summary, achieving proficiency in wireless networking necessitates a comprehensive grasp of its various elements, encompassing components, standards, installation processes, configurations, and troubleshooting methodologies. Welcome to our comprehensive guide on hardware virtualization, where we delve into the fascinating world of hypervisors and their role in enabling the seamless operation of multiple operating systems on a single physical host. In the realm of modern computing, hardware virtualization plays a pivotal role in revolutionizing the way we utilize our infrastructure. At the core of this technological marvel are hypervisors, the software entities that orchestrate the virtualization process and manage the allocation of resources among the various virtual machines running on a single physical server. Hypervisors act as the gatekeepers, creating and managing virtual environments where distinct operating systems can coexist and operate independently, oblivious to the fact that they are sharing the same underlying hardware. This abstraction of hardware resources allows for the efficient utilization of computing power, enabling organizations to consolidate their infrastructure and optimize resource allocation. By leveraging hardware virtualization, businesses can achieve greater flexibility, scalability, and cost efficiency in their IT operations. The ability to run multiple virtual machines on a single server not only streamlines management and maintenance, but also enhances disaster recovery and high availability capabilities. Moreover, hardware virtualization opens up a world of possibilities for experimentation and innovation. Developers and IT professionals can create isolated testing environments, experiment with different operating systems and software configurations, and simulate complex network architectures without the need for physical hardware. In essence, hardware virtualization, empowered by hypervisors, represents a paradigm shift in the way we approach computing. It blurs the lines between physical and virtual, enabling a level of agility and efficiency that was previously unimaginable. So join us on this journey as we unravel the mysteries of hardware virtualization and discover the boundless potential it holds for the future of IT infrastructure.
In the realm of modern computing, the utilization of hypervisor software by a physical host to create virtual environments represents a groundbreaking advancement that has reshaped the landscape of IT infrastructure. These virtual environments, meticulously crafted by the hypervisor, mirror the physical hardware devices required for the seamless operation of various operating systems and applications. At the heart of this innovative approach lies the concept of hardware virtualization, a technique that enables the abstraction and virtualization of physical hardware resources into virtual counterparts. The hypervisor, acting as a virtualization layer, facilitates the creation and management of these virtual environments, each complete with its own set of virtual hardware devices. Within each virtual environment, the hypervisor emulates the essential hardware components needed for the proper functioning of an operating system, such as virtual CPUs, memory, storage, network interfaces, and other peripherals. These virtual hardware devices are presented to the guest operating systems, running within the virtual environments as if they were physical devices, allowing for seamless interaction and utilization. By replicating the hardware environment in a virtualized form, organizations can achieve a myriad of benefits, including enhanced resource utilization, increased flexibility, simplified management, and improved scalability. The decoupling of hardware from software through virtualization enables greater efficiency in resource allocation, as multiple virtual environments can coexist on a single physical host without interference. In essence, the utilization of hypervisor software to create virtual environments with virtual hardware devices represents a transformative paradigm shift in the realm of IT infrastructure. It paves the way for increased agility, scalability, and cost-effectiveness, ushering in a new era of computing where the boundaries between physical and virtual are blurred, and the possibilities are truly limitless.
These environments, known as virtual machines or guests, can run different operating systems simultaneously. Hyper-V is an example that supports both Linux and Windows 10.
The hypervisor is responsible for allocating the host's hardware resources among the active virtual machines that are currently running. This careful and deliberate allocation enables the efficient use of the host machine's overall capabilities. ensuring that each virtual machine can perform its tasks effectively without overburdening the system. Virtualization helps organizations reduce the number of physical systems needed, which in turn leads to significant energy savings. By consolidating multiple virtual machines onto fewer physical servers, companies can optimize their hardware usage.
Virtual environments are made up of files and can be managed using various tools. Diagrams help illustrate these complex setups. Snapshots capture the state of a virtual machine at a specific point in time, allowing for precise recovery options. They are especially useful for restoring systems after unexpected failures or during software testing phases.
We sincerely hope you found this extensive information extremely helpful and valuable for both your academic studies and practical real-world applications. We believe that the insights provided can significantly enhance your understanding and proficiency in the subject matter, enabling you to excel in your educational endeavors and apply the knowledge effectively in various practical scenarios. This comprehensive resource is designed to support your learning journey, offering you detailed explanations, examples, and guidance to ensure you achieve your goals and succeed in your pursuits.
That was the hardware side of the house. We will follow up now with the software side. You have to take 2 exams, one for hardware and one for software, in order to obtain your certification.